What up, algebraists? Here we are. We're starting 1.4 today, and we just looked at this problem. The rule for this, I don't know why I just tossed that book. I'm going to use this. That was weird. Okay, today we're going to focus on how on earth do we get these rules. So, right off the bat, we're talking about arithmetic sequences. And because we're talking about them, we should probably all agree on what these are. We're going to right away hit the definition. Now, your book will approach this as two different definitions. They do sequence and then define arithmetic sequence. We're just going to do them both at once. So here we go, an arithmetic sequence. We're going to define it and work with these. Arithmetic sequence. I use SEQ for my shorthand for sequence, just so you guys are aware. All right. I have up on the board an arithmetic sequence. Can anybody tell me, like you guys identified the rule. How do we go from one term to the next? We add 10. Is there an order to this? Yeah. So we have a list of numbers that has a particular order and it follows the same rule everywhere. Cool. We have exactly an arithmetic sequence. We're going to try to do this as concisely as possible. Do you guys know what concise means? Short. Few words is what we're after. So, Seabass, you're on your calculator. Don't, as long as you're not playing Blockman, I'm cool with it. Cool. All right. Arithmetic sequence. We are looking for an ordered list. So there has to be an order to it. Ordered list, and it's of numbers. I'm not even going to write that. With what is known as a common difference. A common difference between successive terms. Okay. As we look at this, only a couple things that we have to make sure that we can get out of here. Successive terms. I'll let everybody get this written before I ask my next question. I have a cut somewhere there. All right. First off, what's a difference? It is subtraction. So we have to have the same, the same number between every two successive terms. What does it mean to be successive?
Success to achieve.
So 22 and 32 are successive, I would claim. To succeed is to go beyond instead of precede, which comes before. So successive just means after. So if I pick this term, are 22 and 32 successive?
Yeah.
How about 12 and 32?
Yeah.
Does it go one right after the other? Not there. We skipped one, right? They have to be next to each other. Now, with sequences specifically, I think you guys have dealt with some of these. We're going to spend a little bit of time on notation stuff. First and foremost, I'm not going to write it. They're just functions. That's it. Because we're looking at something that we call something different, they're sequences, we're going to use a slightly different notation, but I think you've seen it all. We are going to write our sequences using the following convention. A sub 1 is the first term in my list. A sub 2 is the second. A sub 3, and how long can a list keep going? Keep going forever and ever. But here's the first weird question. This is going to look super strange. Eventually, it would be 4 and 5 and 6. Is there a number n that we will eventually get to? Like a sub n. It could be whatever number, just some big number n. Okay, here's my challenge for you. What's the number right after a sub n? If it's a sub 50, what's the next term? So a sub 0 means a naught. That's usually the first term if you're starting at 0. Oh, because you're using letters. Okay, let's try the numbers. I see what you're doing. I didn't catch that. My bad. If it were a sub 50, what's the next one? How did you do that? I don't think you had to calculate it, but I think you could calculate it. You took that 50 and you did what to it? That just added 1. Do you guys agree that if we did the same thing here to our number underneath, we just call it a sub n plus 1? I didn't write the other one. What would the next term be? A sub n plus 2. And I'm just not going to write that one. I'll just keep going. Was there a term right before a sub n? I didn't put it in here. Can you tell me what it would have been? Nope, we're still going to use n. And minus 1 would have given it to me. So as we look at this, each of these is a term. So I'm not going to write all of them. Here's the first term. right here, a sub 1. I'll skip one just so we can see it. This is the what term? Third term. Okay, challenge. Which one's this? Love it. Whoever, was that Amy? It could be, but I'm guarantee it's the nth term, if nothing else. Okay. This is it. We pick n values to plug in to some rule that we'll write down here in a few minutes, and then it spits out a term at us. Now, every one of these numbers, 1, 2, 3, 4, 5, 6, they're telling us what values can we plug into our function. Are we ever getting 1.2 or 1.3 or 1.4? Did I write down anything between 1 and 2, or did I just go 1 and 2 and 3 and 4? It doesn't make sense to say it's a 3-point-second term, right? That's a weird thing to say. Which means, for these, somebody remind me this symbol. For all. I gave you guys a lot of those symbols that first day. Some of them we'll use a lot. This is one that shows up a ton in math. For all. For all sequences. The domain is, gosh, it's just 1 and 2 and 3 and 4 and 5. Do those numbers have a name? They're not I mean, they are real, but it's not all the real numbers because they don't hit any of the decimals. It's almost the integers. I'm okay with calling it the integers. 0 is not normally included, but I'm okay with using this. So z is the integers. And then I'm going to add one more little symbol to this. If I had a plus sign right here, z plus, I'm referring to integers that are what, you think? Positive. Why would I have to include that? There's negative integers and there's 0, but we don't start at 0, we start at 1. Alternatively, when you guys were little, you don't remember it probably, it's weird if you do. When you teach a kid to count, what's the first big number they learn to count to?
100.
So before 100? 10. Every human on earth, for the most part, learns to count to 10 first. Why 10? You have 10 of these bad boys, right? Okay, that means it's natural to start counting 1, 2, 3, 4. Alternatively, instead of z plus, we could call these the natural numbers. And I always remember the natural numbers because you naturally start counting at 1. Okay, do you want to take a quick sidestep into the history of mathematics?
Yes.
Okay. Natural numbers. Natural for us to count to 10. They counted to 12 or 60. So just different style of counting, but we're all the same. Okay. For these, we, bless you, are going to look at this common difference. So I'm going to make a little asterisk here, an asterisk here. And last little note, the common difference, which we've put it up as a vocab, but we didn't really talk about it. The common difference, we are going to commit to just using the lowercase letter d for this. The common difference, d, can be found, and I'm going to use a colon, and we're going to make this like a main point. If I gave us some sequence, and I already have one here, as long as I have 2 successive terms, I can verify this is an arithmetic sequence, because anytime that I do a subtraction, we're going to get the same thing. So here we go. If I had a list, if I wanted to take a sub 2 minus what term is right before the second? There's an obvious answer. I'm not trying to trick you. The first. Okay, whatever I get with this subtraction, subtraction, that was strange, is going to be the same throughout the whole thing. A2 minus A1 gives me some number. It is the same number as A3 minus A2. It is the same number as A5 minus which term? A sub 4. And finally, it's the same as, and we're going to write this a few ways just so we can see it, A sub n minus, what's right before that? Careful. A sub, what's 1 before n? How would you write that down? N minus 1. All of these are going to be the exact same number. We're going to call it d. If it's arithmetic, you will find this number. And it's really easy to check then if we have an arithmetic sequence or not. So let's dive right in. Example, all I want to know with these is arithmetic with a question mark. And if it is, if yes, I want us to find the common difference. Cool. So let's knock one out, and we're going to make up a sequence here. And let's say that our first sequence is 1, followed by negative 13, followed by negative 27, and negative 41, and this just keeps going forever. We have 2 questions to address, maybe, at least one. If I want to know if it is arithmetic, I just check to see that it has a what did we define it as? A common difference. Do we have the terms in order right now? So let's check. I typically don't write down a ton. I do it like this. If I take the difference between these? Negative 13 minus 1. Everybody, what is it? Negative 14. Everybody cool with that? What if you do these two? Negative 27 minus a negative 13. Why? So this changes to big add, right? Yeah. And so I switch it, the negative is bigger, yeah? Yeah. What's 27 minus 13, and then we'll just make it negative? Oh, it's negative 14. What if we do these two? Was it the same everywhere? Like, it was the difference between any 2 terms next to each other was always negative 14, right? It was common. This is a common difference. Is this arithmetic if it has a common difference? Yeah. Yes. And what is that common difference that we just found? Negative 14. Yep, negative 13 minus positive 1. And then negative 27 minus negative 13. Every time we're doing the exact same thing. Okay, one more for you. What's your favorite number, Ronaldo? 7. Okay, 10, 13, 16, and so forth and so on forever. I want you and your neighbor to determine, is it arithmetic? And if it is, what's the common difference? Super fast. Arithmetic? Common difference? Always. Always, always, always. Now, sometimes it might turn to add when you do that, but always. Ronaldo asked a great question. He said, do you always have to subtract? Yes, it is the common difference. Ronaldo. Angel might have also. Check it out. What's 10 minus 7? 3. What's 13 minus 10? And 16 minus 13? Do we get the same number every time? Arithmetic. So yes. What was my common difference, D? 3. Super hard, right? Okay. One more. Think about it. Don't write it down, okay? 1, 1, 2, 3, 5, 8, ... I want to know if this is arithmetic. Once you make a determination, little fun thing, can you tell me the next term? It might, no, I don't know, I wouldn't call it code. It might be a sequence from Fibonacci, maybe. Why no? If you can justify it, like, 1 minus 1 is 0. And 2 minus 1 is 1. Okay, it's not common. No. No, you're right. Okay. We should be done, I assume, because if we're trying to decide if this thing's arithmetic, you're just going to start trying to find the what?
The difference.
The difference. What's 1 minus 1? What's 2 minus 1? Are those the same? Not a common difference. This is not an arithmetic sequence. Anybody know the rule for this one? The next term is 13. Adding. So 13 is the next one. After that? It's not 15. 21. 34. Anybody see the rule yet? Take 2 terms and add them. What's 1 plus 1? 2 plus 1? 3, or 2 plus 3? Hey, look at that. We can generate the sequence there. Okay, so when we're writing these rules, we're going to jump in tomorrow. Yeah, we're going to jump in tomorrow. We got like 30 seconds left. I'm not going to give you guys homework tonight. Quick check. Who in here does not have a textbook? Okay, for you 3 specifically, let me write down your names. Hopefully we'll get this sorted out. I'm going to reset the passwords on the digital stuff because the Google can't let you in yet. I'm going to get you guys sign-ins so that when you're on the trip, you can still do bookwork and stuff. Cool. Okay, that was Fred, Amy, RJ. Cool. All right. We will continue on here tomorrow.